In this video, I'm going to show you how to factor quadratic expressions when your a value is not 1. So we have the example 3x squared plus 17x plus 10. The first thing you're going to do is you're going to set up your x box, same way you would if a was 1. Now at the top of the x box, you always do a times c. So in this example, 3 times 10 is 30. And then you put your b value down here at the bottom. Now what you're trying to do is you're trying to find two numbers that multiply to 30 but also add to 17, which in this case would be 15 and 2. So now that I know the two factors that multiply to 30 but also add to 17 are 15 and 2, I can move on to step 2. In step 2, I do the famous rewrite, replace, rewrite. So what this means is you are rewriting the a term from your original equation. So in this example, I'm rewriting 3x squared, and I'm replacing my b term with the two factors from my x box. So again, in this example, it would be 15x and 2x. So I rewrote my a term, I replaced my b term. Now I'm going to rewrite my c term from the original equation, which in this example is 10. From here, what I want to do is I want to group my first two terms and my last two terms. So I have 3x squared plus 15x plus 2x plus 10. So I'm grouping my first two terms and my last two terms. Now what I need to do is I need to look at this grouping and I need to factor out the GCF, known as the greatest common factor, from both sets of parentheses. So if I look here, I can factor out an x from both terms because both terms have an x in it, and I can factor out 3 from 3 and 15, meaning that 3 and 15 are both divisible by 3. So what I'm doing is I'm factoring out 3x from both terms, which leaves me with x plus 5. Essentially 3x squared divided by 3x is x. 15x divided by 3x is just 5. And over here, I can factor out just 2 from these two terms because I can't factor out an x because 10 does not have an x value, but I can factor out 2 because 2 and 10 are divisible by 2. So if I do that, that leaves me with x plus 5 within the parentheses. One important thing to note from this step is you know that you have correctly factored out the greatest common factor if you have the same thing in both sets of parentheses. So what I do now is I regroup my terms as the two inside terms and the two outside terms. So my inside terms were x plus 5. My outside terms is what I factored out as far as my greatest common factor. So I have 3x and 2. What I can do from here is I can check my answer by foiling. If I multiply these two binomials, I should get the original equation that I started with. So if I have x plus 5 times 3x plus 2, and I multiply these, x times 3x is 3x squared, x times 2 is 2x, 5 times 3x is 15x, and 5 times 2 is 10. And if I simplify this by combining these two like terms, I get 3x squared plus 17x plus 10, which, if I look back at the first step, is what I started with here. So I know that I factored this correctly. Now, since I factored this correctly, the last thing I can do is I can pull my x-intercepts from factored form. Your x-intercepts are also known as your zeros, your solutions, and your roots. So those all mean the same thing. Now the way that you do that is you set each one equal to 0. So if I had x plus 5 as my first binomial up here, I set that equal to 0 and I solve for x. So in this example, to get x by itself, I would subtract 5 from both sides. So I get x equals -5. And you can write that as a coordinate, making -5 your x value and 0 as your y value. Over here, I take the second binomial that I had, 3x plus 2, set it equal to 0, and solve for x. Minus 2 from both sides. So I have 3x equals negative 2, and then I divide by 3. You're going to get a fraction, and that is perfectly okay. So I have that x equals negative 2/3. So my x-intercept for this example is negative 2/3, comma 0. Okay, so those are the steps for factoring when your a value is not 0. Go ahead and try these examples here. So again, start by x-boxing. A times c goes at the top, so 2 times 6 is 12. And then your b value goes at the bottom. So we're looking for two numbers that multiply to 12 but add to 7. So in this example, it would be 3 and 4. Next, rewrite, replace, rewrite. So I'm rewriting my a term, replacing my b term with the two factors from your x box, and rewriting your c term. Next, group your first two terms and your last two terms and find the greatest common factor that you can factor out of both of them. Now in this example, I can't divide 2 and 3 by any number besides 1, but they both have an x, so I can factor out an x. Here, the only thing that I can factor out of 4 and 6 is 2, so that's what I'll factor out. So this leaves me with x parentheses 2x plus 3 plus 2 parentheses 2x plus 3 again. From here, I know that I factored correctly because I have 2x plus 3 in both sets of parentheses. So now I write it as my inside terms and my outside terms. Last thing you need to do is solve for your zeros or your x-intercepts. So if I have 2x plus 3 equals 0, I would subtract 3 from both sides, which gives me 2x equals negative 3. Divide both sides by 2, so x equals negative 3 over 2. So my first 0 is negative 3 over 2, comma 0. As for this one, I have x plus 2 equals 0. So if I'm solving for x, I need to subtract 2 from both sides. So I get x equals negative 2, which would give me a 0 written like that. So those are my x-intercepts. On to the next example. Same idea. X box, a times c at the top, so 3 times negative 3 is negative 9, and this is a negative 8 for my b value. So trying to find two numbers that multiply to negative 9 but add to negative 8. So in this example, I could do negative 9 and positive 1. From here, rewrite, replace, rewrite. So I'm rewriting my a term, replacing my b term with my two factors that I just got from my x box, and rewriting my c term. Next, group first two terms and last two terms. So if I look at this, from my first two terms, I can definitely factor out an x, and I can factor out a 3. So I'm actually going to factor out 3x from those first two terms. However, over here, I can't factor out an x from both of them, and the only number that's divisible by that I can divide 1 and 3 by is 1. So I'm actually just going to factor out a 1. So what this looks like after I factor out my greatest common factor would be 3x parentheses x minus 3 plus 1 times x minus 3. Again, do your self-check. Make sure you factored it correctly by noticing if you have the same thing in both sets of parentheses. And this one I do, so excuse me, so I know that I factored it correctly. Last step as far as the factoring process, rewrite it as your two inside terms and outside terms. The order does not matter. Okay, to solve for zeros, set each one equal to 0. So I have 3x plus 1 equals 0, and I have x minus 3 equals 0. For this first example, I would subtract 1 from both sides. So if I have 0 minus 1, that would give me negative 1. And then I divide by 3, so x equals negative 1/3. So I can write it as an intercept, or as a 0, like so. And over here, to solve for x, all I would have to do is add 3 to both sides, so x equals 3. Oops.